June 8, 2021, 10:58 a.m. UTC. In the span of 6 minutes, massive chunks of the internet just stopped working. Not one website, not one company. Thousands of websites, simultaneously. Down, Reddit, Amazon, CNN, New York Times, BBC, Twitch, GitHub, gov.uk, UK government, Hulu, HBO Max, PayPal, Spotify not hacked, not attacked, not a solar flare or cyber warfare. One person, one company, one configuration change. 49 minutes of global internet disruption. And here's what should terrify you. 85% of internet traffic flows through just 3 companies. When one of them has a bad morning, half the internet goes dark and the other half checks the downtime detector website. I'm Tony, and this is the Breakdown Economy, where we examine failures to reveal patterns you need to see. Today, how Fastly's configuration error proved that the internet isn't actually distributed, and why centralization is the invisible single point of failure we've all accepted without realizing it. To understand how one company can take down half the internet, you need to understand what a CDN actually does. CDN stands for Content Delivery Network. And despite the boring name, CDNs are critical infrastructure for the modern internet. Your website, hosted on one server, in one location, say Virginia. User in California wants to access your site. Request travels 3,000 miles to Virginia. Server processes request. Response travels 3,000 miles back. Total round trip, 6,000 miles. Latency, 100-200 milliseconds. Now multiply that by millions of users. One server in Virginia trying to serve the entire world? Slow, expensive, unreliable. How a content delivery network works, the modern approach. Your website, uploaded once to CDN, copies content to hundreds of servers worldwide. With edge servers in California, London, Tokyo, Sao Paulo, Sydney, etc. When a user in California wants to access your site, CDN routes to nearest server, Los Angeles. The request travels 100 miles instead of 3,000. A response comes back from the local server. Latency around is about 10 to 20 milliseconds, 10 times faster. Why CDNs became essential: speed, content served from nearby servers. Reliability, if one server fails, route to another. Scalability, handle millions of users without one server melting. DDoS protection, absorb attack traffic across distributed network. And cost, cheaper than running global infrastructure yourself. This is how. Netflix streams 4K video without buffering. Amazon handles Black Friday traffic. News sites survive breaking news spikes. Apps feel instant no matter where you are. CDNs are invisible to users. You don't think about them until they stop working. The CDN market. Now here's where it gets interesting. The CDN market is extremely concentrated. Major CDN providers: 1. Cloudflare, 30% of top 1M sites. 2. Fastly, 8% of top 1M sites. 3. Akamai, 15% of enterprise. 4. Amazon CloudFront, AWS ecosystem. 5. Google Cloud CDN. Combined, 85% of internet traffic flows through these 5 companies, and on June 8, 2021, one of them had a very bad day. Fastly, founded in 2011, IPO 2019, known for high-performance CDN, edge computing capabilities, serving major brands, Reddit, NYT, gov.uk. Market cap: over 5 billion major customers using Fastly. Reddit, entire platform. Amazon, parts of infrastructure. New York Times, CNN, BBC, UK government websites, GitHub, Shopify, Stripe, Twitch, and thousands of major websites, utilizing one CDN provider. What could possibly go wrong? All right, let's break down exactly what happened on June 8, 2021, because the cause was shockingly simple. The impact was catastrophic. The incident timeline. 9:47 UTC. Fastly engineer deploys routine software update. Standard process. Tested in staging. Should be safe. 10:47 UTC. Customer deploys new service configuration. Uses features from the software update. It triggers a bug in Fastly's code. Cascading failures begin 10:58 UTC, 85% of Fastly's network goes offline. Edge servers worldwide stop responding. Customers' websites return 503 errors. Monitoring systems light up red, 1101. UTC, social media explodes. Twitter trends, internet down. Users discover, wait, all these sites use Fastly? Concentration risk becomes visible. 1144. UTC, Fastly identifies root cause, software bug, and configuration validation. A specific customer configuration triggered it. 46 minutes of downtime. 11.47. UTC, services begin recovering. Network comes back online. Sites gradually restore. Total outage, 49 minutes. 49 minutes. That's all it took to disrupt. E-commerce, billions in potential sales. News during major events. Government services, UK visa applications, etc. Financial platforms, entertainment services. And the cause? Well, here's what actually caused the outage. The bug. Step 1. Fastly deploys software update with new configuration validation logic. Step 2. A customer uses the new feature to configure their service. Step 3. Configuration passes validation, but contains an edge case. Fastly didn't test. Step 4. When edge servers try to process this configuration, validation bug causes a crash. Server restarts automatically. The server tries to load the same configuration. It crashes again. Boot loops begin. Step 5. 85% of edge servers enter crash, restart loops simultaneously. Think of it like this. You update your phone's operating system. New feature lets you customize notifications. You customize them in a way the update didn't anticipate. Your phone crashes, restarts, loads your settings, crashes again. Now imagine that's not your phone. That's 85% of the internet's edge infrastructure. Why didn't testing catch this? Edge case not in test suite. Specific combination of settings. Rare configuration pattern. Tests covered common scenarios, not this edge case. Staging environment different from production. Production has scale testing, but it doesn't replicate. Cascading failures only appear at scale. Customer configurations were unpredictable. Can't test every possible combination. Customers use features in unexpected ways. This isn't unique to Fastly. Every software company has this problem. You can't test everything. But when your software runs 85% of the internet's edge infrastructure, the blast radius of "we didn't test this edge case" or "knew to do so" is catastrophic. So how did Fastly fix it? Step 1. Identify the bug. 18 minutes. Monitoring showed crash restart pattern. Logs revealed configuration validation issue. Traced to specific software update. Step 2. Disable the problematic feature. 10 minutes. Can't roll back. Edge servers in boot loop. Push configuration to disable new validation logic. Servers restart successfully. Step 3. Restore service gradually. 18 minutes. Edge servers come back online. Customer sites begin loading. Monitor for stability. Total recovery time, 46 minutes. Why recovery was relatively fast? Fastly immediately acknowledged the outage, transparency. The engineering team quickly identified the root cause, had rollback capability, disable feature, public post-mortem explaining what happened. Fastly's transparency. Real-time status updates. Detailed technical post-mortem within days. Explanation of bug and fix. Commitment to preventing recurrence. Compared to other outages, Fastly handled this well. Fast identification. Quick fix. Transparent communication. But here's the thing. Good incident response doesn't change the fundamental problem. 85% of the internet, depending on one company, means when they have a bad 49 minutes, so does everyone else. Let's talk about what those 49 minutes actually cost. Measurable impacts. E-commerce losses. Amazon, over 5.5 million in sales, minute, estimated 220 million lost. Other e-commerce platforms, hundreds of millions collectively. News blackout during major events. CNN, NYT, BBC, Guardian offline. Critical news day, G7 summit, global events. Couldn't access authoritative news sources. Government services disruption. UK, gov.uk down. Visa applications, licenses, citizen services. Emergency services info pages offline. Government accountability gap. Developer productivity. GitHub down. Code repositories inaccessible. Millions of developers worldwide blocked entertainment. Streaming services offline. Gaming platforms disrupted, sorry gamers. Content creators lost revenue, Twitch, etc. Financial services. Payment platforms intermittent. Trading platforms affected. Transaction failures. But the real cost wasn't dollars. It was exposure. For 49 minutes, the world saw, wait, all these sites use the same company. The invisible infrastructure became visible. The concentration risk became obvious. And nothing changed. So Fastly had an outage. They fixed it. Life moved on. But why does this matter beyond one incident? Because Fastly proved 3 patterns about modern infrastructure that most people don't understand. Pattern number 1. The internet isn't distributed, it's centralized. The internet was designed to be distributed. The original vision, 1960s, 1980s. No single point of failure, decentralized architecture, route around damage, resilient to attacks. The internet we think we have. Thousands of independent networks, millions of servers, decentralized and resilient. The internet we actually have. A couple of CDN providers with 85% of traffic. 3 cloud providers, AWS, Azure, Google. 70% of hosting. 3 DNS providers. Most critical infrastructure. Handful of ISPs in each region. We consolidated for efficiency. Why companies centralize on CDNs, cheaper than building your own infrastructure. Faster deployment, better performance, easier to manage. But consolidation creates single points of failure. Similar Fastly-style outages. AWS US East 1 outage, Oki 2025. DNS resolution of the DynamoDB API endpoint. Down 15 hours, affecting gov.uk, Delta and American Airlines, AT&T, Microsoft 365, Ring doorbells and camera, Venmo, McDonald's, Coinbase, Signal, and other major services. Why? All hosted in the same region. AWS US East 1 outage, DEC 2021. Single AWS region fails, takes down Netflix, Disney+, Robinhood, and other major services. Why? All hosted in the same region. Cloudflare outage, July 2020. Configuration error. Half the internet offline, similar to Fastly. Why? Concentration in one CDN Akamai outage, July 2021. Edge DNS failure. Major sites down. Why? Centralized DNS infrastructure Google Cloud outage, Nov 2021. Networking issue. YouTube, Gmail, Google services down. Why? All run on same infrastructure. The pattern. We built the internet to be decentralized. Then we centralized it for convenience. And now, when one component fails, thousands of services fail. This is the opposite of resilient design. Pattern number 2. Efficiency versus resilience is a trade-off we've forgotten. Let's talk about why companies consolidate onto a single CDN. Maximum resilience approach. Use multiple CDNs. 50% traffic. Cloudflare. 30% traffic. Fastly. 20% traffic. Akamai Pros. If one CDN fails, others keep running. 50-80% of traffic continues. Resilient to single provider failure. Cons. Complex configuration management. Higher costs. Multiple vendor contracts. More operational overhead. Harder to optimize performance maximum efficiency approach. Use one CDN. 100% traffic. Fastly Pros. Simple configuration volume discounts. Cheaper. Easier to manage, better performance optimization. Cons. Single point of failure. If CDN fails, 100% of traffic is down. No redundancy, most companies choose efficiency. Why efficiency wins? CFO. Multi-CDN costs 40% more. Engineering. but it's more resilient to outages. CFO. When was the last major outage? Engineering. Never with our current provider. CFO. So we're paying 40% more for something that's never happened? Engineering. Denied. Until it happens. Then, CFO. Why didn't we have redundancy? Engineering. We proposed it. You said it was too expensive. CFO. Implement multi-CDN immediately. 3 months later. CFO. We haven't had an outage in 3 months. Why are we still paying for multi-CDN? And the cycle repeats. The pattern. Resilience is expensive and invisible when it works. Efficiency is cheap and visible immediately. So companies optimize for efficiency. Until disaster strikes. Then they temporarily prioritize resilience. Then cost pressure returns. And they drift back to efficiency. This isn't unique to CDNs, supply chains. Efficient, single supplier, just in time. Resilient, multiple suppliers, redundant inventory. COVID exposed. Everyone chose efficiency power grids. Efficient, interconnected, optimized load. Resilient, isolated segments, redundancy. Texas freeze exposed. Efficiency over resilience, financial systems. Efficient, centralized clearinghouses. Resilient, distributed settlement. 2008, exposed, too big to fail. Centralization risk. We always optimize for efficiency until the failure that proves we needed resilience. Pattern number 3, invisible dependencies. Create unexpected failures, and here's the most dangerous pattern. Most companies didn't know they used Fastly. How invisible dependencies work. Your website uses Shopify, e-commerce platform, which uses Cloudflare, CDN, which uses AWS, hosting, which uses Akamai for some services, which uses Fastly for edge computing. You think, we use Cloudflare, we're fine. Reality, Cloudflare uses Fastly for X. Fastly is down, you're down. June 8, 2021 examples. Reddit. Knew they used Fastly directly. Expected to be affected. Down. Amazon. Didn't think they used Fastly. Use Fastly for parts of their infrastructure. Partially down. Surprising. UK government. Main sites used Fastly. Known. Some services use vendors who used Fastly. More affected than expected. The pattern, you can't protect against dependencies you don't know exist. Modern software stack, application layer, your code, framework layer, React, Django, etc. Platform layer, AWS, Azure, Google Cloud, CDN layer, Cloudflare, Fastly, Akamai, DNS layer, Route 53, Cloudflare, DNS. Monitoring layer, Datadog, New Relic, Analytics layer, Google Analytics, Segment. Each layer has dependencies on other services. Failures propagate in unexpected ways. When Fastly went down, some companies discovered, wait, what, we use that? I thought we switched off Fastly last year. Our vendor uses them, so we're affected. You can't manage risks you don't know you have. And in modern infrastructure, dependency chains are opaque. All right, so what do you actually do with this information? Whether you're running infrastructure, choosing vendors, or just understanding risk, here's what matters. If you're managing web infrastructure, critical actions to reduce CDN concentration risk. Action number 1, map your actual dependencies. Don't just list direct vendors, Cloudflare, AWS, etc. Map second-order dependencies. Who do they depend on? Identify single points of failure in the chain. Questions to ask. What CDN do we use? Direct dependency. What CDN does our hosting provider use? Indirect. What CDN does our payment processor use? Indirect. If any of these fail, what breaks? Action number 2, implement multi-CDN if you're critical. Multi-CDN makes sense for e-commerce, downtime, direct revenue loss. SaaS platforms, uptime is your product. Media, news, breaking news, traffic spikes. Government services, citizen services, critical. Multi-CDN is overkill for personal blogs, internal tools, low traffic sites, non-revenue services. Multi-CDN costs 40-60% more. Only worth it if downtime costs exceed the premium. Do the math. Downtime cost calculation. Revenue divided by hour. Uptime guarantee. Cost of additional nines. Example. Revenue. 10 million a year, 140 hour. Single CDN uptime, 99.9%, 8.7 hours downtime year. Multi-CDN uptime, 99.99%, 0.87 hours downtime year. Savings, 8,600 plus per year in avoided downtime. If multi-CDN costs more than the avoided downtime, it's not worth it financially. Action number 3, have documented rollover procedures. Even if you don't run multi-CDN actively, have a contract with backup CDN document how to failover quickly. Test failover procedure annually. Preposition configuration. This gives you single CDN cost savings, normal operation. Ability to switch if primary fails, emergency. Downside, failover takes hours, not automatic. Upside, cheaper than active multi-CDN. Action number 4, monitor your vendor's dependencies. Subscribe to the status pages of your direct vendors, their major dependencies, if known. Set up alerts for your CDN, major cloud providers, AWS, Azure, Google. Major CDN providers, Cloudflare, Fastly, Akamai. Follow infrastructure Twitter accounts. Often hear about outages before official announcements. When Fastly went down, companies that quickly recovered had monitoring in place, saw outage within minutes, activated incident response, communicated with customers proactively. Companies that struggled, discovered outage from customer complaints, didn't know they used Fastly, scrambled to understand dependencies. No communication plan. If you're choosing infrastructure vendors, questions to ask vendors about concentration risk, vendor assessment questions. What's your relationship with major CDN cloud providers? Exclusive partnership, concentration risk. Multi-vendor sounds more resilient. What happens if Cloudflare, Fastly, AWS goes down? Good answer. We fail over to backup automatically. Bad answer, that's never happened. Do you run multi-CDN or multi-cloud? If yes, how does failover work? If no, why not? Cost versus risk trade-off. Can you provide a dependency map? Shows who they depend on, reveals concentration risks. What was your uptime during recent major outage? Tests if they were affected. Shows if they have resilience. Red flags. We're 100% on AWS, single cloud vendor risk. We use Cloudflare exclusively, single CDN risk. We've never had a major outage. Luck, not design. Our uptime is guaranteed 99.9%. Doesn't account for dependency failures. Dependency failures don't count toward SLA. Read the fine print. Uptime guarantee excludes third-party service failures. So, when Fastly goes down and takes your vendor down, you have no recourse. If you're just a user, for regular people wondering, is the internet fragile? The reality, the internet is more centralized than it appears, but outages like Fastly are rare. Hours per year, not days. Companies are getting better at resilience. Most critical services have some redundancy. What you can do? Don't panic when sites go down. Likely CDN cloud issue, usually resolves in minutes to hours. Follow status pages for critical services. Twitter often reports outages fastest. Down Detector shows real-time issues, have offline alternatives for critical needs. Banking, keep phone banking as backup. Communication, multiple platforms, WhatsApp, Signal, SMS, news, multiple sources, not just one site. The Fastly outage was disruptive, but it also wasn't catastrophic. 49 minutes, inconvenient, not a disaster. Pause. The concern isn't Fastly going down for 49 minutes. The concern is, what if it was 49 hours? What if it was 49 days? What if multiple CDNs failed simultaneously? We've centralized internet infrastructure, assuming failures are independent. But what if they're not? What if a zero-day vulnerability affects all major CDNs? What if a coordinated attack targets centralized infrastructure? We haven't tested that scenario. Let's talk about what happened after Fastly's outage. Immediate aftermath. Fastly published detailed post-mortem. Fixed the bug. Improved testing procedures. Stock dropped 8%, then recovered longer-term changes. None. Companies didn't suddenly adopt multi-CDN. Infrastructure didn't suddenly decentralize. Concentration risk didn't decrease. Because fundamentally, efficiency still beats resilience in budget meetings. Here's what the Fastly outage teaches us about modern infrastructure. We built systems optimized for the 99.9% case. They run efficiently. They scale beautifully. They cost less. But we forgot to design for the 0.1% case. When a critical component fails, everything fails simultaneously. The internet looks decentralized. Millions of servers, thousands of networks, distributed globally. But the control points, the CDNs, the clouds, the DNS, are extremely concentrated. 85% of traffic flows through 3 CDN companies. When one has a bad morning, half the internet goes dark for 49 minutes. The question isn't, will this happen again? It did in October 2025. The question is, next time, will it be 49 minutes? It was about 16 hours. This is the breakdown economy. I'm Tony. Next week, the pattern analysis finale, examining what connects all 9 breakdowns we've covered, and the 3 meta patterns that predict the next disaster. Subscribe to see the patterns before the breakdown happens. And if you run infrastructure, map your dependencies this week. All of them. Because you can't manage risks you don't know exist. I'll see you next Thursday.